Now let's look at example 2. So let's take a look at a limit where the graph does not actually equal the function value. So here we have a new equation. So here's f of x. And it's x squared minus 16, all that quantity divided by x minus 4. So this time when I go over here to my calculator, I'm going to type in x squared. I'm going to go ahead and hit the division sign now just to make sure the whole grouping gets divided here, the whole quantity, x squared minus 4. Now, when I type this in, my values aren't looking right now because I want to know when it's approaching 4. So I'll start with the value 3 here, and then I'll have like 3.5, then we'll call it 3.9. I'm just picking values that get closer and closer to 4. And then this will be the value 4, and then 4.01, 4.1, 4.5, and 5. So you can just kind of see I'm getting closer and closer here on my values, and I'm going to take this graph and zoom in. As we get closer and closer to this value 4, the graph appears in there to be approaching the value 8. That's what it looks like to me, and the table is showing the same thing. But we can, if we zoom in here, what's going to happen when I get to 4, you'll see that it has an open circle, which means the graph is undefined there. This is a removable discontinuity, if you remember that from lesson 1.3. So this has a removable discontinuity there, and at 4, it's undefined. The function itself is undefined, but that does not mean the limit is. Because what happens is we zoom in on that spot as the graph approaches this point. We can estimate the limit, which again, the limit does not mean where does the graph actually exist, it's where is the graph approaching. This graph is approaching the value 8. So even though this is undefined, we would say that the limit of x squared minus 16 over x minus 4 as x approaches 4 will still equal the value 8, even though the graph itself was undefined. So just because the graph is undefined doesn't mean that the limit will be. So it can exist even if the graph itself does not. So I'll let you try this one. We'll call it DOL number 2. Estimate the limit. And here you should have a picture that matches with it.